Okay. We've got 6, so maybe let's start.
Okay. So hi everyone, welcome to today's guided onboarding session. My name is Katerina. I'm social media, content and community manager at SpecFlow, and he is my colleague Jordan. He's a user journey support engineer at SpecFlow. And today we will hold this webinar together. So I hope you will enjoy it and find it useful for you. So it's a hands-on session, so you have to follow Jordan. He will show you step by step how to use SpecFlow, install SpecFlow. If you have any question, please use our QA tool for questions. Upvote interesting questions, and we will answer all of them at the end of the sessions. When there's questions that are relevant to the task, I will interrupt Jordan and ask him these questions, and he will answer them. And before we start, let's start with a quick poll. I'm launching the poll. So can you see it, Jordan?
Not yet.
Oh, okay, 1 minute. Now.
Yes.
So the first question, have you used SpecFlow before?
So hopefully there'll be some learnings from 67% of people haven't, so that's good.
And poll, and now I'm showing results.
Cool,
so
good.
Most of the people know us, that's good. And yes, so thanks a lot, and let's start.
Yeah, I'll share my screen. Cool, thanks for that, Katerina. So for anyone that hasn't used SpecFlow before, obviously this session is for you guys to get an idea of what SpecFlow is, how it works and how to get started with it. So that's what we're going to be covering today. If I'm moving along too quickly, for people that are following along, then do pop something in the chat. Maybe Katerina can just give me a nudge. And likewise, if you can't see it very well and I need to zoom in, then also let Katerina know and she can let me know. Cool. So with that said, let's get into the session. So the first thing we need to do to get started with SpecFlow is we need to decide which IDE we're going to be using. So today we'll be using Visual Studio, but we also have a plugin for Rider, and that includes if you're using Rider on a Mac as well. So that's super useful. So once the IDE has launched, we're just going to continue without code for now because we want to install the extension, and just give me 1 moment while I move this toolbar out of the way. So in Visual Studio at the top, you should have this extensions tab. So you can click that and go to manage extensions. And from within here, if we search online for SpecFlow, we'll see this SpecFlow for Visual Studio 2019. So that's the one we want to install. So for anyone using Visual Studio 22, we already have an extension for this as well, so you can go ahead and use that. So to actually install the extension, we've instructed Visual Studio that we want to install it, but we actually need to close the IDE for the installer to run. So this might just take a moment, but you should see something like this. And obviously we want to modify our install. And this will just take a moment. And basically what the extension is one, it gives us access to some cool project templates to help you get started a bit quicker. And 2, basically allows us to write Gherkin syntax and allow Visual Studio to understand what a feature file is effectively. So we'll get into that in just 1 moment. This is taking longer than normal, so that's typical. There we go, good. So you can see here, you should see this little tick box to say that everything's good. We can close this down, and now if we relaunch your IDE, we should be good to get started. So now we've got the extension installed, that we need to actually create a new project. So first, go on.
One question, can we follow it using a Mac?
Yes, so if you're using, so the only official support we have for Mac is if you're using JetBrains Rider IDE, and we have an official plugin for Rider. There is a plugin for Visual Studio for Mac, but it's not an official plugin from SpecFlow. It's in another open source project maintained elsewhere. So For the purposes of this webinar, it would be good if you could use either Rider on Mac or Visual Studio, or you can try and follow along in Visual Studio. But if you come across any issues, I guess I'm not best equipped to maybe try and resolve those. But yes, we do in a nutshell. So now we have this SpecFlow project template, and that is coming from the extension we've just installed. But first things first, we actually need to create something to actually test. So what we'll do first of all is we'll create a class library, and we'll call this SpecFlow calculator. So we always use this calculator as a template because it has some nice simple functionality that we can quite easily demonstrate how it can be tested. So we get this target framework. So honestly, anything should be fine. I'll choose .NET 5. In fact, no, I won't. I'll choose .NET 3.1, and we'll click create. And we should hopefully see the IDE open with our dummy project in here in just one moment. Cool. Let me know if I'm going too quickly, anyone, if you're trying to follow along. So we need to have a look in our Solution Explorer window, and we'll see that we've got this SpecFlow calculator project here. And by default, if you're not familiar with Visual Studio or other IDEs, we get this default class 1. So we're going to remove this because we're going to add our own. So you can just right click on that, go down to delete, and it should get removed. So let's add a new class. So you can right click on your project, come down to add, and then at the bottom of this list, we'll see class, and we'll call this calculator. So this is going to be the class that we're testing. Okay, so obviously our calculator needs to do something. So I'll make this public first of all. And our calculator is going to be very basic. So effectively what it's going to be is going to have 2 numbers, and then we're just going to add those 2 numbers together. And in the end, we'll check the result to make sure that our calculator is working as expected. So we need to create a couple of properties to store those numbers. So there's a shortcut in Visual Studio. There's a keyword prop. And if you press tab twice, it automatically generates this property. We're going to want to store integers. So if you tab again, you can then rename this. So we'll call this first name. And then we need a second property. So again, prop, tab twice, and tab again for the name. And we'll call this second number. And then our calculator actually needs to do something with these numbers. So we'll create a method. And obviously it's going to return an integer, and we'll call this simply add. And all it will do is return the sum of these 2 numbers. So if I could spell, it will return first name. Sorry, I just realized I've called it first name. That's obviously not useful. First number, this is what we wanted. Cool. Return first number plus second number. Cool. So now we've got some form of a basic calculator for which we can actually use as our subject to test. So next we need to create a test project to include our tests. So if we go to the solution here, we can add new project, and this time we'll use the SpecFlow template. So you should see that here. If not, you can search for the template up here, and you'll see it here, SpecFlow project, and we'll click next. And we're going to call this SpecFlow calculator .specs. You can call it .tests, whatever you fancy. So we'll create that. We should see another page here, and we'll keep the target framework .NET Core 3.1. But if you expand, any frameworks that you've got installed should appear in this list. And we'll keep the test framework, the SpecFlow runner. But of course, you can use your favorite test frameworks, NUnit, XUnit, MS Test, whichever you fancy. But for the purposes of this demonstration, I will use the runner. And there's also this neat little checkbox here to add by default the Fluent Assertions library. So if you're not familiar with what that is, we'll definitely cover that when we get to it, but it's a library that we like here because it's really readable, and that's why we like it. So I'll click create. Cool. So we've now got our SpecFlow project, and you'll see that we have a bunch of kind of boilerplate or template folders, one of which has our calculator feature in. And this didn't happen by magic. This is just a default template that we include. So yeah, if you have a look in here, you can see that we have one scenario called add two numbers. It's almost like we planned this, but this will be our test effectively. So what I'm going to do quickly is I'm just going to build the solution to make sure that that it builds. So my screen's disappeared and it's back. Is it visible, Katerina, my screen?
Yes, yes.
Did you witness it go black, or was that just for me?
Oh no, everything is fine.
Okay, good. Sorry if that happens again. Yeah, technical difficulties. So we can see that the project is built, and that's excellent. And now we should see some tests appear, or a test appear in our Test Explorer window. So I guess just to cover anything off, if you don't see this Test Explorer window here on the side, you can see this test tab at the top here, and then you should see this option for Test Explorer. So if you click that, then the window will appear. And the same should be very similar in JetBrains Rider if you're having difficulties there. Good. So we have our test here, and you can see it's all in gray. You know, we've not run it yet, but it's acknowledged the fact there is a test, and that's literally come from this feature, this default feature file that was generated by default. So for example, if I just quickly add another test in here, let's just call it test 2, just for the sake of demonstration and context. If we do another build, we should then see we've got another test in here. So just like with your unit tests, every test will get picked up in the Test Explorer window, and you can see it here, test 2. So we'll get rid of this. And what we're actually going to do is just execute this test. So we'll run this, and we'll wait to see the output. Okay, so it's saying at the bottom here that the test run is finished, but nothing actually executed. So if we go to the output window and we select show output from tests, we scroll up here, we can see, if we do a little bit of investigation, that the runner has tried to execute the tests, but we get the sign up. So if you've not used the runner before, then you actually do need to register to use it. If you're using any of the other test runners, then you obviously won't see this, but anyone following along with the SpecFlow Plus runner, then you will, at least if you haven't used it before. So we can control and click on this and just follow this link. And I'm going to just do this login off the side because I'll be required to enter, obviously, my personal credentials, but this is what you should see. So you can only sign in with a Microsoft account. So let me just, I'm in a VM, so you guys are all going to have to see this, but that's fine. Let's click next here. Oh, I wonder if I can just quickly.
Oh, you use Hotmail.
Yeah, this is historic. Yeah. So if you haven't activated before, haven't gone through that process, then there'll be some additional information that you haven't seen today because I've already done it. But it basically just asks for some basic details about your organization, your name, and things like this. So don't be alarmed by that. But hopefully you get to this page. And as I'm talking, hopefully people are going through this as well. I'm just giving people a bit of time. But you'll see that we should be able to switch back to the IDE, run the scenarios again. And this time, the scenario should actually execute. So let's go ahead and do that. And we'll just click run all. Just while this is running, is there anything in the chat that's relevant for me, Katerina?
Not actually.
Okay, good. Cool. So we can see the tests have begun executing. And I wonder what we will see this time. So let's have a look. So you see there's this exclamation mark here. So something's not quite right. So if we have a look at the output, we'll see the first step that gets executed, given the first number is 50, and this directly correlates to our step in the scenario. we can see that it actually says pending. So, and you can see the method that it was calling. So let's investigate that. So to navigate to the implementation for any given step, you can right click on the step, and you should see this go to definition option. And you can also see there's a shorthand or shortcut for this, which is F12. So I'll use that. And this is where our implementation resides. So you can see we have this calculator step definition, and the step definition files are where the implementation would exist for your features. Okay, so if we scroll down, we have this given the first number is, and then this weird symbol here, which is actually a regular expression. So I won't go into too much detail for now in this session, but this is how the compiler matches the feature step to a particular method where it needs to join to do the execution. So we have this parameter here, and it automatically identifies that this is a number based on the fact that we've passed in this number here. So you can kind of see, if I zoom in a little bit, you can see this is gray and the rest is black. So this kind of denotes that there's a parameter that's expected. So you can see here that that's what it's expecting. And when the test execution happens, that number automatically gets passed into this method, and you can do whatever you want with it, which is super useful. So the pending status, you can see, comes from here. So we've, by default, set this pending status. So it means you can't trip over yourself. You have to do something here. You have to do some implementation. So that's what we'll do next. So the first thing we're going to do is get rid of all this because we don't actually need it. But we do, however, need a reference to our calculator. So I'm going to generate a constructor. So CTOR is the keyword, and you can tab twice and it automatically generates a constructor. It just saves you having to write this out yourself. And what we'll do is we'll make use of SpecFlow's parameter or constructor injection, and we'll automatically inject this class at runtime into this class. So we called it calculator, yes, not calculator step definitions. We'll call this calculator, and we need to obviously add a reference to the project, which we missed. So if we go to our SpecFlow calculator in the Solution Explorer window and we right click, we can add a project reference, and we'll add a reference to our SpecFlow calculator because we need to access the logic from within inside of that project. And if we come back here and you see this message, or you did until it resolved itself, and now we have access to the code that we created. So we need to actually create a local field for this. So a shorthand or quick way of doing that instead of typing it is if you use Control and Dot. IntelliSense will say, would you like to do these things? And we'll click the one that says create and assign a field calculator, and it does everything for us, which is super useful. So now we have access to the calculator. Let's just give it a build, make sure everything's happy. And obviously it's not going to be because I've removed the reference to, let me just make this a bit smaller, the scenario context. So actually I'm just going to get rid of this because we don't need them anyway. And this last one here. And now we'll do a build and it should be happy. Cool, and you can see at the bottom here, build one succeeded. So let's get rid of this so it's nice and clear for everyone. Excellent. So now we need to actually do something with our calculator. So we're expecting to do something with this first number that gets passed in here. So if we whip back just for a bit of context, we're saying that given we add two numbers, or sorry, the scenarios add two numbers, and given the first number is something and the second number is something, when we add those numbers together, then we expect some result, right? So let's go back to our calculator step definitions. So what we need to do is assign this value to our calculator. So say this dot calculator dot first number equals number. So that takes care of the first number assignment. And likewise for the second number, say this dot calculator dot second number equals number. So we've handled our numbers. But what we need to do actually is we need a local field to store the result of this, this summation. So we'll create a new private field and it will be an integer. And we'll call this result. And that way we can store the result from the addition. So we'll say this dot calculator dot add, which is at the top here. And we need to assign this dot result. Cool. So the add method returns the summation as an integer, and we're assigning that value into our local field, which is the result. And now we can do our check, right? So we've got the expected result here, and we need to check it against the actual result. So let's do that now. So we'll say this dot result, and this is where we see the fluent assertions library stuff come in. Should, and if we select this and do the control and dot, we'll see IntelliSense is saying, would you like to use fluent assertions library? Yes, we would. And then there's this nice flow here. So you can see this result should be, and it's obviously expecting, because this is an integer, it's expecting us to do a comparison against this. So, and this is the expected result. So you can see it's nice and fluent, as the name suggests. So it's clear. So this result should be the result. So let's do a build, make sure everything is good. Cool. Looks like it succeeded. So let's re-execute this and see if we get a passing test. And we do. Cool. Perfect. So we can see all of the steps here have completed. So given the first number is 50 and it's called the method, and again for the second one, and then we've done the addition and then the assertion has passed, and therefore we get a passing result in the window here. So that's all well and good, but a calculator usually can do a bit more than that. So let's extend, let's add a test, okay? And this will kind of showcase how we can reuse steps with SpecFlow, and also how we create new steps. So for the sake of simplicity, let's just copy and paste this one, and we'll call this subtract two numbers. And we need to change this one here, of course. So now what we have is we're reusing the first step and we're reusing the second step. This one doesn't yet exist, but we'll handle that in just a second. But we can also reuse the third step, which is the fourth step in this case, which is the then step, the assertion step. So before we go any further, let's just adjust these numbers, because if not, it's doomed to fail. Cool, so that should handle that. And you can see this unbound step here, that's what we call it when a step has no definition, it's called unbound. So we actually want to add a binding to this. So if we F12 on this, because it recognizes the fact that there is no binding for this, it says no matching step binding found. Do you want to copy basically a skeleton of the binding to the clipboard? And yes, that would be super handy. So we will do that. And it saves you having to write these out, manually. So we can literally paste this into our step definition. And now if we go back to our calculator feature, this is basically resolved. And we can see that it's turned black. So that means the feature file is happy. And then we need to come up with some implementation for this. So similarly, we'll say this dot result, this dot calculator dot, and we'll call it subtract. If I can not mash the keyboard like this. And obviously we don't yet have a definition for this method. So for the sake of time, you can also control and dot on this, because it, IntelliSense can tell that there's no matching implementation for this. And we can generate the method calculator.subtract. So if we go back to our calculator, we'll see now there should be a blank line. And there is. So we'll need to just quickly do our implementation. And we'll do the same again, first number, but this time we'll do minus second number. And that should give us the result that we need. And just like that, we have added another test, but we've reused 3 of those existing steps. We've only had to do some subtle changes, but the value is great. So let's build the solution again, make sure that everything looks good. And it does. So now we see the second test. So let's run them both to make sure that everything is okay still, and we haven't broken anything. I see there's a question in the Q&A. Is while we wait,
I answered the question in Q&A.
Okay, cool.
And Matt said thank you for me.
Okay, perfect, cool, good. So we can see that both of these have passed, so that's wonderful. And, you know, the world is the limit, the sky is the limit. You can, you know, carry on adding tests. We could do, you know, multiply, divide. For the sake of time, we won't do that, but you get the idea. We could literally copy and paste these in, change the one step that basically does the action in the when step, and the rest is just reusable. So it's super nice. Just before we move on, I will just mention if you're adding steps, you don't have to write this out manually. We do have a template for it, so you can come down to the steps folder. So say if you've got another piece of functionality you're looking to test, you can right click on the steps folder and add, and then we go to new item. If you search in here, you'll see that you should see SpecFlow step definition, and we'll just call this new, just for the sake of ease. I'm just showcasing, and you can see, excuse me, that it has also a template, but you get the idea. We get all of the using directives and the binding here. So this is important. This binding attribute needs to be here. Otherwise, they won't get picked up by the compiler as being related to our feature file. So, but if you use some templates, you should never really have to worry about that anyway. And I'm just going to delete this because we'll be using this project going forward. Cool. So that's kind of the basics of SpecFlow and the project template and how to get started. What I'd like to show now is kind of the bit you would do after you have a project, which is our SpecFlow Plus or SpecFlow Living documentation, which ultimately is a nice way of sharing your features and your tests or your examples, however you want to call them, with people that might not necessarily have access to the repository or, you know, have the technical skill set to open the IDE and view these things. So it actually generates a HTML file, which is easily shareable, and it's nice, and it makes everything pretty to look at. So the first step you need to take is to go to the command line, and I'm just going to open the chat window because I'll just paste the command in. 2 seconds. So we need to install the CLI tool. So we have 2 versions of this tool. One is a command line interface, and the second one is an Azure DevOps plugin. We'll be covering the command line interface today, but you can navigate to our documentation to view how to get started with the Azure plugin too. So the command, which isn't copying and pasting from my local machine. There we go. So let me paste this in the chat so you guys can also install it. If we hit enter here, we should see that it executes, hopefully, and we should get some green wording that says it's been successful. Please execute. Here we go. Good. So now we can see we can now invoke the tool with the command living doc, and this is the version that was installed. So we're basically ready to go. And all you need to do to generate the living documentation is, so one thing I should mention is there's a dependency which will be included in the project template, but it's this plugin here, this SpecFlow Plus Living Doc plugin. So if you've already got an existing project that uses SpecFlow, you can also install this from the NuGet package manager. and then you can continue basically just from where we started here in the command line. So that's worth noting. This is required when using the command line tool to be in your project. Cool, so let's continue. So the next thing we need to do is obviously invoke the tool. So the command, as mentioned here, is living doc. And then we need to point to the test assembly that's for this project. So let's go and fetch that. So if we come into the File Explorer and go to this PC, go to our local disk, and basically just look for where your repository or your project is stored. And we'll go into SpecFlow calculator.specs, which is where the tests reside, into the bin folder and the debug folder, and this folder here. And we should see in here what we're looking for is the DLL for our test project. So if we just filter by type here, so we're looking for an application extension, and we're looking for specflow.specs.dll, which will be here somewhere. Sorry, SpecFlow calculator.specs.dll. And if we shift and right click on this, we can copy as path. So this is the path to the test assembly. So we'll paste this in. So we can do two things here. We can generate this as is. In fact, I'm going to do that just to show you how it works. So this gets generated into the project root folder. Here, sorry. So it gets generated by default into the users folder here. So if we open the living doc that gets generated, and by default it has the name living doc. You can obviously change this should you wish to. Let me just get rid of this little pin thing here and close this down. And this is what gets generated as a result of that command line interface. So you can see the folder structure here. And inside of our features, we have the calculator feature, which directly correlates to what exists in the project. And we can see our two tests here. But one thing you might notice is there's no test results, but we can actually generate the living doc with test results. And the reason we gave the option to do with or without is, you know, maybe your project's not doing so well and there's a lot of failing tests. A lot of red can be scary for people like BAs or product owners or scrum masters and things. So yeah, you can either exclude them or include them. And you can see here we get a breakdown of the particular steps that were executed, any tags that were included. So maybe I should talk about tags in just a second. And you can filter by these tags. So you can, let me just flip back to the IDE, go to our features. So this tag here, maybe we want to easily find these. This could be tag add, and this could be subtract. So let's just build this again and regenerate just to showcase the point. We need to wait for it to finish building before we redo this. So let's regenerate it and refresh it. And you can now see this add tag and subtract tag. Maybe these tags are reused across the project and we want to filter by these. Maybe you've got environment specific tests. I'm not sure why you would, but you can filter by tags and we can search for those, these things. And it will return basically a list of tests that include this tag. There's other things you can do with these tags, like you can link them, for example, to you know, Jira tickets or Azure DevOps work items. So you then would be able to click these links and they would take you to the, you know, test case work item they were related to, this kind of stuff. You might notice here, I'll fix this in just a second, this picture is missing, but you can add pictures here, you know, whatever you like really. A description, so this is this text here that you can see. And this is just Markdown syntax. So for anyone that's familiar with Markdown, it should be very easy for you to add things like links, pictures, whatever you want really. And you can read more about the technical details and what you can and can't do within our documentation, which I'll link you to at the end of this session. But now let's generate these with test results so you can see what that looks like. So the filter for this is -t. And we need to grab our test execution JSON, which is why we needed the that plugin installed in the project, the Living Doc plugin, because it actually generates that file for us. So if we scroll down, we should see this here, test execution.json. And again, I'll shift and right click, copy as path, paste this in, and we'll regenerate this. And this time, if we refresh, we get our test results, which is really, really cool. So I guess if you're running in parallel, what you'll see is each execution. So if it ran 3 times, then you'll see those results in here. There's also this analytics tab, which breaks down the tests by which test passed by feature, by scenario level, and also at the step level. So you can see maybe there's some dodgy steps in your tests. Might be easier to kind of figure out which features it's affecting. We have this unused step definitions section here. So in the event that, you know, maybe you've got a big project or someone's failed to do some tidy up. So if we just copy and paste this one here for the sake of demonstration, we'll call this test and this test, and we rebuild this. So now, I mean, we know because we've written these tests that this isn't being used anywhere at all, right? So if you imagine if you have a massive project, people are doing refactoring, they're making changes to features, stuff is inevitably going to get left behind. And this is perfect for this. So we'll just regenerate this document. And now if we refresh, we should see under analytics that we have one unused step definition, and it tells us the name so we can go back and do our tidy up, which is really cool. So that's kind of it for Living Doc. I will just fix this image because I do want to kind of show. I think I put a link in here. Yeah, I did. Cool. So I'll just paste this straight into our image here. Save it and rebuild it. And we'll generate this again. And now we should see a picture of a calculator. Yes, we do. Cool. So you can see how you know, this could be used much nicer to share this information with your non-technical team members, like your product owners, so they can also see how it's getting on. Could also be used by your BAs if you've got BAs, you know, in your discovery sessions and things like this. Just gives it a nice way of being able to see this stuff a bit more cleanly. So that's kind of it. That's it for now. So Katerina, if I can ask you to.
So I'm sharing in my screen. Can you stop your sharing?
Sure.
1 minute. So can you see my screen?
Yes.
So now it's a quick poll. So let me. It's the last poll. Stop. No. Okay, can you start the poll? I mean,
Yeah,
it's something.
sure. Yeah, no worries.
I see. So no
You got
worries.
it?
Mm-hmm.
Okay, cool. There we go.
So here's the poll. Can you please answer? So did you follow along and create your own project? Okay. No.
See, this was why I wanted to ask this question, because I've just. Oh, good. Someone did. Excellent.
Okay.
Good. And hopefully I wasn't moving too fast, and hopefully you were able to imitate what I was doing. So whilst that poll is running, it's probably over, to be fair. There's 2 people happened. But let me, so that's good to know, first of all. So thank you for following along. Hopefully it's been useful. Let me just grab a link to our documentation.
Mm-hmm.
So, and that you can find out more details about how everything works. You know, if you're interested in Living Doc or just finding out a bit more about SpecFlow, then you can follow this rather unsightly link.
We also share the recording, so you can just sit and follow them,
Yes.
slowly enjoy them.
Yeah, and there's been many onboarding webinar before this one, so all of them are on YouTube. Obviously, pick the ones with me and Katerina in, because we do the best job. Cool. So let's move on to the Q&A then. Looks like we're
so this is one probably not question, but can you please show how to parallel run for the test created just as an example?
Yeah. let me share again. 2 seconds. Let me know when you can see. All good? Okay, wicked. So what we need to do is we need to add a file into the project. So this is only relevant, of course, for the runner. There is implementations of parallel execution in NUnit. I've never used XUnit in this way, or MS Test. So I'm sure there is implementations for parallel execution, but I couldn't tell you off the top of my head. So what we need to do is we need to right click on our test project and go to add a new item. And we're looking for a file called runner, sr runner, no, sf runner. Did a great job here. What's the file extension called? Here we go. SR profile is what I wanted to do. And I'll just keep this as default SR profile. And within this profile, you can see that we have this execution settings. So we have stop after failures 3. So what that means is the tests will execute 3 times. And if they fail after 3 times, then we won't continue to execute that test. This is the number of threads. So we've got 2 tests in this project. So I'll add this to 2. If you're running this locally, I wouldn't recommend using too many threads because obviously, it consumes a lot of CPU resource. And we also have this test scheduling mode, which basically you can run them sequentially, you can run them randomly. I'll put a link to the docs so you can see how that stuff all works in just a second. So if we now build this again and we execute these simultaneously, you should see that they both run at the same time and we get a much faster result. And that was very quick, but give it 2 seconds. This is much more apparent with when you're testing much more complicated things. Let me just check something. I'm going to grab the docs, paste it in the chat window. So that's all you need to do is add this file, specify how many test threads you want, and then you can read into the documentation about how you can further extend this stuff because there's a lot of things you can add to this file. Yeah, that's it. That's all. So is there another question?
Yes, there's another question. So is calculator class injected as a single tone or scoped? Suppose that we have 2-step definition class that calculator injected.
Let me just reread this. Calculate class injectors. I believe it's as a singleton with, so behind the scenes, SpecFlow is using our Bodhi project, I guess you could call it, BODI. And I believe by default, because it's a simple kind of containerization tool or dependency injection framework, I believe they're all singletons, but we do also have we support other dependency injections frameworks like AutoFac, and there's another one. I can't remember off the top of my head, but it is in the documentation. But obviously, you can use your own dependency injection frameworks quite easily this way, and then you can scope them. You can scope the objects kind of as you choose. So, yeah, that's it. I think that's. Is there any more questions from anyone before we move on?
Okay, probably no.
Okay.
So
cool. Then let's.
So I stop share. Can I share? So stop your sharing. Can I?
Oh yes, yeah. There you go. We should be good.
So share my screen. Can you see my screen?
Yes.
So that was yay. Before we end, I'd like to draw your attention to our SpecFlow Community Hero program. The idea is that if you submit a contribution to SpecFlow, it can be GitHub contribution, video content, text content, for example, in case of article, we will review it and give you $25 Amazon voucher. So I'll post a link. Okay, oh, Jordan, can you post a link?
Yeah, I'll post it, yeah.
So Jordan, and please click the link and give it a try, and we'll really appreciate it. And then also thank you for your for today, and thank you that you found time to be with us today. I hope it was interesting and informative for you. And here you see links to our social media channels. Please follow us, like, comment, share our posts. We will really appreciate it. Thanks a lot and have a nice day. Have a nice evening.
Thanks, everyone.
Bye-bye.